All right, guys, this is section 5.3. There are some things you need to know. Things like term. Term is a number or a product of number and variables raised to powers. Okay, so if we look over here at this example here, x squared is a term. Negative 6x is a term. 7 is a term. Okay, and then you also need to know the definition of a coefficient. A coefficient is the numerical factor for each term. So for x squared, the coefficient would be 1, and so on and so forth. So let's fill out this. So we would have x squared minus 6x and 7. You will be given some problems like this, and you need to be able to fill out either if it's a coefficient or the term. So x squared has a coefficient of 1. You don't see a 1 in there, but it's implied, just like we've talked about. And this is 7. Okay. Some more things, some more definitions. The degree of a polynomial is the greatest degree, aka the exponent, of any term of the polynomial. So if I look at this example, 2 plus 3x, what's that degree? Well, 2 has a power of 0, a variable of power 0, and x to the third has a power to the third. So it's the greatest degree, and that is, so therefore this one's degree is 3. If I looked at this example, it'd be 3x. 3x has a power of 1, so that would be the degree of 1. But 7x to the fifth has a power of 5. So the degree of this expression is 5. Okay? Another thing you need to know is monomial, binomial, and trinomial. Okay? A monomial is a polynomial with exactly one term. So that could be 3x cubed, or just 5, or negative 7x squared. Those are all monomial terms. Binomial is a polynomial with exactly 2 terms. So that example, 2 plus x cubed, that's a binomial. Let's call it 3x squared minus 7x. That's another binomial. Okay, so they have to have exactly 2 terms. And a trinomial would be like 2 plus 5x squared minus 7x cubed. That's a trinomial. It has 3 unique terms. All right, moving on. You're going to be asked some questions like this. The average tuition, fees, and room and board rates change per year for full-time students at a certain college is approximated by this polynomial function. 2.6x squared plus 3.71x plus 2,856.6 for each year from approximately 1984 to 2006. Use this model to predict what the cost will be for a student at the college in 2017. So in approximately x equals 33. Okay, you are literally just making x equal to 33, so you'll have 6.2 times 33 squared plus 37.1 times 33 plus 2856.6. 33 squared. All right, so this first bit is 6,751.8 plus, oops, 1,224.3 plus 2856.6. You sum those up, and you come up with 10,832.70. So that's how much it would cost to go to college approximately based on this equation. Okay, so you're going to have several of those, and they're going to say, evaluate this equation when x equals this. So you're just plugging it in and following our order of operations. All right. You also might get something, you're going to get some things that look like this, and they're going to say simplify. Okay, this is where you're going to combine like terms. Okay, so like terms, they have to be exactly the same. So x squared is not the same as an x, okay? So every time the degrees have to match up. All the variables have to match up to be similar. So in this first example, you have this and this. So you have 0.3 minus 1.8 y squareds. They're both y squareds. They're both like terms, okay? So you just take the numbers in front of them and do the math. So that gives me negative 1.5 y squared. And numbers are the same. So I have 6.7 minus 1.3. So that's going to be plus 5.4. Okay. From here, I cannot combine the y's and the numbers. They're not the same. Let's look at this next example. Okay. I was telling you they have to be exactly the same. Well, here's the only catch in the rule. If you are doing it, has to look exactly the same, you're going to say, there's absolutely nothing that's like terms. But I'm going to tell you, yes, there is. So x squared y, x squared, those are the same. Because remember, a times b is the same as b times a. So the order of multiplication doesn't matter so long as they're the exact same. So I would have 3x squared y minus 3yx squared. So 3 minus 3 gives me nothing. So, all right, so I took care of those. My next like terms are these. They both have y squareds and x's. So I have 9x y squared minus 3y squared x. So what is 9 minus 3? That's 6x y squared. And then all I'm left with is plus 6. Okay, so don't let it try to trick you too badly. Remember that the rule of multiplication doesn't matter the order, the answer's still the same. The other thing you're going to have is to write the following polynomial in descending power of the variables with no missing powers. So if I look at this first example, it is in descending order, but what it doesn't have is it has variables missing, okay? So what's lower than x cubed? Well, I need an x squared. Do I have that? No, so I need to make sure I have an x squared. And I also need to make sure I have an x before I get to the number. So that means I'm going to start off with 5x cubed. And I can add plus, and I need x squared, but I can't change the original expression. So that means you put a 0 in front of it, and then you can do plus 0x, and then minus 67. Okay, let's look at this other example. Here, what am I missing? Well, I'm missing an x to the fourth, I'm missing an x squared, and I am missing just a number back there. Okay, so you need to make sure you add those numbers if it doesn't have a number. So you start off with your highest exponent, which is 7x to the fifth, plus 0x to the fourth, plus x cubed. And you can, instead of saying plus, you can say minus 0x squared minus 3x plus 0. It doesn't matter if you do plus or minus 0, it's still the same. Good luck with the homework and email me with any questions.